Okay, now for a little condensed lesson on making functions from cyclical data. So if it's going up and down, kind of like the tides, or maybe the amount of sunlight that you have during the year, you can write a trig function for that. And normally you would think you would use sine, but you don't. You use cosine. And I'll tell you why in a minute. So let's get to our first page. Here we have just a graphadil, you know, like daffodil, you get it? And I'm going to twist this in and just remind you, what does tangent look like? Well, if I had a tangent graph, I have dotted lines. Those are for the asymptotes. And then a line like this. That's tangent. Normal tangent would have pi over 2 and negative pi over 2. But what about 8 tangent? Well, the normal tangent goes up 1 and it gets about halfway across. See where I put the dot there? And then going down 1, it gets about halfway across, halfway between the y-axis and this dotted line asymptote here. So those 1 and 8 change, 1 and negative 1 change to 8 and negative 8. Then this 4, that is a horizontal thing. Seems like you'd times by 4, but you don't. You times by 1/4. So now I'm going to multiply everything by 1/4. That's this 1/2 pi. I multiply it by 1/4, turns it into pi over 8. And same thing here, of course, it changes it into negative pi over 8. All right, so there, all I had to do was change my labeling, and I've got my answer. All right, so I'm not going to make you do all of these because of the condensed nature of these videos. I'm just going to move on. I'm going to talk about some data here. A population in this town has gone up and then back down again, and then it's probably going to go up and down. And there are places that are like that, especially if you have seasonal workers coming in to work, or maybe even seasonal visitors, like people going to Hawaii. Although Hawaii is pretty popular all year round. People coming to Minnesota to enjoy the beautiful weather in June, July, and August. So there's times when things go up and down. Well, what do you think the key part is? The moment when it gets its highest, of course, is key. And here it appears that it hits 13 as its highest in the 4th year. And then another time it gets to the highest right here in the 16th year. It appears to be at 13. I'm assuming that's 13 million people. Who knows? Maybe it's a very small town. Although then these decimals probably wouldn't make sense with it. All right, so we're going to go with that means like 13 million people. So the two high spots, if this was going to be sine, sine would look like this. The two high spots would be like two places where sine reached its peak. But I've told you before that we're going to use cosine. So here's cosine. It goes down and back up again. Do you see if I have two high spots? That's kind of important because I've got the two spots where it reached its peak. All right. Now, another thing to be handy is if you knew what the lowest was that it ever went. And this one appears to, in the middle, right in between 4 and 16, it hits 11. So right here, like here's at year 10, which happens to be 6 years away on both sides, so 10 is exactly in the middle. It has a low of 11. Now, how is this different than normal sine? Well, normal sine has a high of 1 and a low of negative 1. And, sorry, this is cosine. And this clearly isn't normal cosine. So we have to look at it and say, what's different about this? Well, ours is, I'm going to make a new graph for it here. I'm going to shrink this down a little bit. Ours has a high spot of 13 in the 4th year, and another high spot of 16, at year 16, it has another high spot of 13, and it's going to go down in between, right? But how low does it go in between? It goes down to 11. So, do you see what I just did there? I just took cosine and said, look, here's the high spot, here's the high spot. I know it goes all the way down in the in-between time, and it hits 11 there at year 10, which happens to be exactly 6 years, in between 4 and 16, 6 years on each side. All right, so now I'm ready to write the equation. So how do I actually write the equation? I write y equals cosine, and then I stop and ponder for a moment. Now, remember that there's several things in here. I'm going to use A and B, and then there's theta, and then there's a shift of, let's actually have that be factored out, and then there can be something after that, like plus 5 or whatever. Okay, so that's our C and D terms. This is like C and this is like D. So I got to figure out A, B, C, and D of this equation. So this is not a super easy concept. No, it's not super hard either, but we need to figure out A, B, C, and D. Well, first thing, let me counsel you in this. First thing to do is figure out the midline, the line that runs right down the middle. All right, so the line that runs right down the middle here would be exactly between 11 and 13. Well, to me, that must mean it's at 12. And that midline, do you remember that that's at the end? Because my cosine must have been shifted up 12. Does that make sense? All right, next thing is, how far is it for its amplitude? Like, what is this thing's amplitude? Well, it goes from the midline up. Remember, the amplitude is not the total distance like this. It's not that. It's from the midline up. And so that, how far is that from 12 to 13? Well, that's a 1. So I can put a 1 right here. 1 cosine of, and next I got to figure out how far has this thing been shifted. That's what's inside here. And I'm always going to say it's been shifted to the right. I know that seems strange, but you could shift the cosine graph to the left or to the right and still end up getting it to this spot. So that, for normal cosine, wouldn't it have started there? Its high spot should be at 0, but it's been shifted over that far. Okay, so this is a shift over of 4. It's really small. I'm going to try to do that again. This distance is 4, and so I'm going to erase to make myself a little room here, and then see if I can zoom in and write minus 4. Okay. Then what's the last thing? This is the toughest thing. This is the B term. There is no B term right now. I'm going to have to squeeze one in there in a second. And so the question is, what is the B term? All right. So I'm going to go back to that equation I've been saying over and over and over again, that the period is 2 pi over B. Okay? So the period is supposed to be 2 pi if this is normal cosine. Well, we all know it's not normal cosine. But what is the period? The period is the time it takes to get a complete cycle done. All right? And how far is a complete cycle? Well, when it goes from its peak to its peak. Now, I'm going to tell you, a lot of times that we aren't going to be able to go the whole thing. We're going to only be able to go from the peak to the valley, in which case that's not a complete cycle. You'll have to double it if you only find that far. All right, but since I happen to have 2 peaks here, I can say it goes from 4 to 16. Its complete cycle took how long? 16 minus the 4 is 12. Its period was 12. Now that I know its period was 12, do you get I can solve for B? If 12 equals 2 pi over B, I can solve for B. I'm going to multiply both sides by B, and I get 12B equals 2 pi. And again, I'm trying to solve for B here, so I'm going to divide both sides by 12. And now B is equal to 2 pi over 12. Can I simplify that? Sure. Pi over 6. So that pi over 6 goes in the B spot, which I'm going to put right here, pi over 6. There we go. I've got the equation that will make this data happen. I obviously got it in the other order. I got the data first, and then I was able to write the equation. But isn't that cool? You could figure out an equation that then you could use to predict the future. you know, like right now on our graph, when it hits 22, that's it. That's the end of our data. We can't tell anymore. But if we know it's going to keep doing this same pattern, we could put in theta. Remember that the x values are on the top there, so that's the theta. We could put in a theta of like 70 and find out whether it'll be at the peak of its cycle or the bottom of its cycle. And so these equations can then be used to predict what y would be, which is like this, which in this case is the number of people. All right, so I'm going to back up and just say, what did I do there? I figured out the equation using cosine. And the reason I used cosine is because it's so easy to tell how far over it's shifted. You just have to take the peak, the first peak that you come to, and that goes right here. And you'll just say that cosine should have its peak at 0, but instead it has its peak over here at 4, and therefore there's a 4 that goes right there. Okay, this is always where the midline goes, and this is the amplitude. Once you have the midline, it's really easy to tell how far up is it going. What's the highest it goes above the midline? And that, in this case, was 13 minus the 12 was 1. So it was an amplitude of 1. And then this part comes from that equation I've been saying over and over again, that period is 2 pi over b. So you figure out how big the period is, which is how much time it takes to complete a complete cycle. You put that in here and you solve for b. All right, let's see now if you can tell how to do this next one. So imagine for a moment that we had to answer this. The table shows the depth of water over a 5-second period as waves pass the end of a pier. So if these waves are consistent, and the height against the pier, which is basically like that pole in the water, at these times, I'm looking for, what number do you think I'm looking for? I'm looking for the highest that it ever goes. And what is the highest that it ever goes? It looks like it hits 11.8 is the highest it ever goes. Now notice I don't have another high spot. You remember me telling you before that you aren't always going to have two high spots? But I do have the highest spot, which is here. That's where the depth was at 11.8. And I do have the lowest spot, which was, well, what's the lowest number you see, Mr. Server? I appear to have a 10.2 as the lowest number. So this is my low, this is my high. Okay, so my low was at 1.5 comma 10.2. Now I'm going to graph that. So that's over 1.5 and up 10.2. And I'm going to put a dot right there. That was my low spot. Now for my high spot. My high spot was at 4, and the highest it ever got was 11.8. So I'm going to say that that over there is at 11.8. Now you got to think of this as a cosine wave. It's been shifted. All right. Now, would it be going up here? Yes, but it wouldn't have reached its highest. That curve's kind of the wrong way. Let me try that again. It wouldn't have reached its highest all the way at 0. Okay, so what you do is you start by saying, always use cosine. Oh, it's already got a f of x there. I should use that. So f of x is like y equals cosine. Always use cosine because then you can do that shift first. All right, so how far has cosine been shifted? This is where it should be. It should be over here at 0, but instead it's there. How far over has it been shifted? It's been shifted over 4. So to put in my shift, I'm going to make more room and be able to write a little bigger here. So this is going to be cosine of, I use theta for my variable. You can totally use x if you want to. The shift is always right because it's going to always be to the right. And however far that is, which is the x value of that, which is 4. It's been shifted to the right 4. Because if cosine would have been normal cosine, the peak would have been back here at 0. All right, so it's been shifted right 4. Then I need to figure out its amplitude. Do you remember me saying the midline is really, really important and you should do that early? Sometimes I even say do that first. I didn't do that first, but I can do it now. So what's exactly between 11.8 and 10.2? Hint, exactly between means the same as average. So I'm going to average these two. If I add 10.2 and 11.8, that's going to be 22. I take 22 divided by 2, and I get 11. So it's telling me that 11 is exactly between those two. Now I want you to think about that. How far off is this one from this one? 0.8. How far off is 11 from 11.8? 0.8. Ah, it's working. It's 11. So 11's the midline. So you're going to put an 11 there? If cosine had been shifted up, that's how far up it would have been shifted. Okay, next, to figure out its amplitude, I'm going to look at how far from the midline up does it go. 11 up to 11.8, that's a 0.8. And then last but not least, I got to figure out my b term. And for this, I need that formula. That formula, as I've recited a few times, is period is 2 pi over b. Now, when wouldn't it be 2 pi over b? Only with tangent. Tangent and cotangent have a different period. Their period would be just pi. But I'm not using tangent right now, so I use 2 pi. All right, 2 pi over b. Do I know b? No, that's the whole point. I need to figure out b, but I know the period. The period is how long it takes to complete a complete cycle, and I get this all the time. Kids will say, oh, so it goes from here, the low spot, to here, which is the high spot, and they subtract those two, and they say 2.5, which is the difference between here and here, but it's not 2.5. The period is not 2.5. The period is how long it takes to go from like the low spot to the next low spot. So you have to double the 2.5, which makes the period 5. Get what just happened there? Instead of just subtracting these two, I had to double them because I was going from a low spot to a high spot, and I needed to go from a low spot to another low spot, so it's going to be twice as far as you would think. So it's not 2.5, it's 5. Now I'm going to multiply both sides by b, and I have 5b equals 2 pi, and then I'm going to divide both sides by 5, and that makes b equals 2 pi over 5. So that goes right here, 2 pi over 5. And there is my equation, f of x or y equals that equation, which can now predict at any given time what the wave height will be. Now, you all know in the real world waves aren't that consistent, but in a model world, or if you're using things like sound waves, etc., things are going to be more consistent sometimes, and you can use these equations. All right, so I want to keep this short, and that's probably too late for that, but at least I don't want to go over and over these. If you want to, you can always rewatch the examples, and I'll do some more with you when I see you in class. Have a great day. Oh, one more thing. You probably want to know what your homework is. Let's see if I can give you that ahead of time. All right. I am going to use these, I believe, in my in-class time with you. And then I am going to assign you to do practice with this page. And I'm going to have you do that page. And I'm going to have you write an equation for that page. I think we're going to skip that one. That one's just you graphing them with your calculator, and so I don't think that's worth your time. There we go. Have a wonderful day.